Hey, welcome in guys. Got some new prototype stuff to test now. I've had tons of stuff being made at the factories and some delays and things, so this is now working through. I thought we might as well test them live and see if they work, or if we need to fix them, we'll probably do that on live as well. But hopefully they're going to work and then go into production. So what I'm doing at the minute, I'm chucking the one thing I need. I'm just stripping an existing console because this is my personal GBA. So this has got a laminated clean screen end, clean amp, and the clear green shell. It's got the Pokemon Emerald I'm playing through, and it's got the clean juice in at the minute. And what I'm doing now is I'm replacing these custom clean juice, which I've sold for years now. They're basically a custom LiPo and a circuit on top that charges them and handles them. I'm going to replace this now for a new range of products that's much cheaper because we don't have to make the custom LiPos, and it's going to be AA batteries. So it's going to recharge rechargeable AA batteries, which means now anyone can buy a clean juice without having to pay extortionate amounts of shipping to get the board, because it's not going to ship with batteries if you don't want to, and you can just buy rechargeable AA batteries local to you to save on shipping costs. So it's going to help make the clean juice a lot cheaper. It's going to be better for longevity because now you're not having to deal with custom LiPos that, say, we ever got rid of the company or anything happened and you couldn't buy our LiPo batteries, then you're not going to be able to renew these when these batteries age because they're custom made for us. Whereas the new version we're making now is going to use AA batteries. So regardless of what happens, you can always maintain that going forward without needing, custom parts off us. There's also many more benefits. People are starting to clone more and more of what we do. So it's time to switch up what we're doing now. And we're going to offer a clean juice that is cheaper than even the ones on AliExpress. So the new version, we're going to make that many of them. We're going to make about 2,000 in the first batch, get the price that low, and undercut even China at their own game. So even if they copy our products, we're going to be selling them cheaper. So we'll start with the GBA. I just needed the battery springs after this because mine was using a clean juice where you remove the battery springs, and obviously this new one you don't need to remove anything. It's completely cut free and drops straight into place where the AA batteries go. So I've just restored that battery spring in there now. GBC one we're doing right after this, as well as GBO and GG. They're all going to get replaced for the AA version. And on top of that, we're also making our own AA batteries. So we're using the factory that makes custom batteries, and we're making 5,000 AAs with our logo on, fully certified. So they're not, it's not just a random place. This is a place that actually makes OEM batteries by the probably millions a year, I'd say. We're just having our wrap put on them so they look nice. But then you've got the option of buying the clean juice AA with rechargeable AAs if you want the convenience, or optionally you can buy it without. So you've got both options really, to buy it without AAs and buy your own, or you can buy branded ones that we sell. So let's take a look. We have the samples box here. Now, I haven't even opened these yet. I've cut the box open and seen the samples inside, but they're still sealed. Backplate, the kits come with them, but it's just our USB-C backs. So every shell that you buy, if you buy off us, it comes with a normal complete AA cover with no hole in, and it comes with a USB-C hole, so a clean juice hole. If you buy the clean juice AA, which is what the product in here is going to be, these are the samples. Then it's going to come with the clear battery cover anyway. So you've always got the cover. We've got some nice Game Gear secrets in here as well. And I think that's it for now. So we've got some Game Gear boards to test there in a minute. And we have, obviously, the new samples of these clean juice AAs. Now, I probably need to test this. I might need to use one to solder to or bench power, because if this doesn't work, we're going to be injecting the wrong voltage into the console. So let's take one of these first, I reckon. So we've got 2 samples made, and this is because I've already made one version of this, the very first revision, and worked great, but because the rechargeable AA batteries are 1.2 volts, not 1.5, the Game Boy needs a entire different circuit. So you can see all the components I've baked in here. This now not only recharges AAs, it's also got a voltage regulator that boosts the voltage back up to a clean 3.4 volts, and a low battery detect here to monitor when the rechargeable AAs get low, and then output the trigger to the GBA to turn the red light on. So it was a bit more complicated than I was hoping. So this is the second revision with those bits added, basically. And I've got the 0.1 mil thick, and I've also had them made in 0.2 mil thick. So the only difference with this is the slightly thicker, and you'll see why when we come to test it. Yeah, I designed all this circuit, every single part of it, invented the idea, made the circuit, we're testing it. So this is literally everything you see hardware-wise with CleanJuice on. This is me designing it and making it. So I've done every single part of this. We've even had a custom USB made because we wanted this to fit perfectly in here. And it's a very specific layout that makes it fit. So we have to have a custom USB. So this slides right the way through. And you've got wiggle room to install it. And then when it's installed, it looks nice like that in the back of the console. So you get a nice little visual in the back when it's closed up. This doesn't require any installation whatsoever. This is, anyone can do it. No soldering, no tools, no nothing. Just a set of rechargeable AAs, and then just place it into the console. So if this works, this is going to be really cool. And then this is going to be much cheaper. So this will be, I can work out a price now for you and let you know what this is going to cost. But it's going to be ridiculously cheap. You will not find a cheaper GBA rechargeable battery solution anywhere, not even in China. So let me just work out the price now, because I got the price in this morning and I've not even calculated it, but I can tell you right now. PC Engine we've got here. I might do a little bit. I'm just too excited because I've got the prototype stuff coming. So we're going to work through prototypes first. Let me just, I want to quickly see what this is going to cost roughly. Well, exactly. And all I need to do is find a product that costs similar amounts in my system, and it will calculate for me. What costs about the same? If not, I can just make another product. To be honest, let me just make the product because it's going to, I need to add it to my system anyway. So I'm just going to add a product. It's going to be barcode GBA. Why do I feel like GBA 50 is a code we already use? So I'm just checking my online system that manages all of the products, and I'm just going to make a new SKU. Yeah, so 50s are the covers, 79s are after, so it's going to be probably GBA 100, 101. Yeah, we've run out of codes, so it's going to have to be 171. Is there a 172? GBA 1, right, so it's going to be GBA 172. That's going to be the SKU. Let's clone the original. GBA 172. I will put CleanJuice AA. We will battery power, USB-C, blah, blah, blah. I'll fill in all the details after. The cost is going to be, let me pull up my actual cost at factory, and then my system is going to work out the profits that we sell them for. Keep going, right, there we go. So put that in there. You're going to like this price though, I can guarantee you. We will offer it as wholesale. We don't need the battery tag in. Large letter 1.5. Right, if I save that now, and let's reveal the price this is going to sell for. Someone's wishful at I say you're wishful at £8.99. You're not far off. It's going to sell at £13 plus tax. So if you're outside the UK, it's £13. If you're inside, it's 13 plus 20%. If you buy 10, it's going to be £11.79. And if you buy 30 or more, it's going to be £10. And that's for the whole product. That's including the packaging, the Clean Juice AA, the USB-C back cover. And then obviously I will offer it with AAs as well as an option soon. So funny enough, the top left is a little TikTok like thing meter. So the more you smash it, the more it appears. But yeah, some people are getting mental on that. So let's say 4,500 likes. Somebody's got one of them. Got to have one of them screen tappers. Yeah, so this is the product. I will show you what happens. Basically, you get this. I don't know whether I can't just plug it in because I need to test it. But what you'd do is you'd put your rechargeables in here. Now, the problem with rechargeables is the 1.2 volts that these are. The voltage is too low. So when you turn on, this will work, but at max volume, max brightness, and playing things, this will usually start rebooting. So let's see if we can get that happen. And I think I've got LEDs I can turn the brightness up on as well. So let me just see if I think this has got the old school ones. Yeah, so that's now maxed out, and usually you can get this to restart fairly easy. These are going to be probably max charged, so no, in my luck you won't get this to happen. But the problem with them, trust me, this will restart basically because the voltage could be too low on these things. So we'll leave it maxed out, and all you have to do to install this is take this product. Now you want to bend these down like this. So you just want to bend them down once as well. You don't want to bend back and forward because these will survive so long as you're bending them the once. But if you're bending them back and forward over and over, you're going to potentially fracture these. So that's why I've had a couple of thicknesses made, because I'm going to see if the 0.1 or the 0.2 last longer. Now all you have to do is push them through the gaps here. So we have to line them up between the battery springs and just push down. And I've tried this on the other ones. The 0.1s are too flexible, so they're definitely too flexible to push through. So we'll go to the 0.2s. That was probably what we already had made before. And we want to bend these down. Yeah, these are much better. So you don't want the 0.1s. You want 0.2. That's got the flex on, and then these have got enough strength now to just push through the batteries like this. So they just literally put, oh, I know what I do actually on the install. Tell a lie. I take them out. I put, I did all this to figure out the best way of installing them. I put the batteries in like this, I believe. I put that resting on, put the battery in like so, put that battery in like so. So the first springs are naturally now wedged between there. So that's your board in. And then you fold this over and you just push these through the springs, and that works. But we don't want to do that yet because we haven't tested this product basically. So if I push this in and this voltage is wrong, we might do damage. So what I need to do first is bench power this. No, the batteries go in first. The way we install it, I tried a good few ways. You just basically rest that there, install the batteries, fold over, and these push down through here. So we'll see that in a minute. But what I need to do first is test it actually works. So we've got these test points on so that when it's installed in the system, you can use a multimeter and actually test if these pins are right and working. But for now, I'm going to use them to actually solder wires to and make sure this is working right. This will be available for GBC. Once this is done, I'll pretty much rapidly make it. So we've got the ground there, and I only need the 2 battery pin. So this I'm going to apply 2.4 volts, which is, well, the battery's fully charged. Can't remember off the top of my head. They're not 1.2 fully charged. That's the nominal. That's the, the main part of the life cycle that it's in. But these are 1.28, so we call it 1.3 volt. So we're going to put 2.6 volt into these pins using the bench power. And then we want to monitor because This actually, like I say, regulates and boosts things. So the output on the GB pin here will be a regulated output voltage if this works. And I really hope it does. But this is a whole new design using new chips, and I can tell you from experience, even if you design the circuit just right, following data sheets and everything, you can get products that just don't work as they should. I've literally had it on, what was the last product I was doing with a 10-volt boost circuit for a charge? I can't even remember, but basically I was designing a circuit where I need to boost a low voltage to a high, just for, I think it was 500 milliamps, and the circuit only outputted 100 milliamps before collapsing. And it turned out to be the chip was actually, even though it's mass sold on DigiKey and available and certified, it doesn't work. It's rated at 3 amps, and it can't handle more than 0.1 amps. So I even brought their evaluation board, which is their pre-made board by the manufacturer that is definitely correct in case it was something I'd done wrong with the PCB layout. And their evaluation board could only handle 0.1 amps. And yet they're sitting selling it as a 3 amp chip. So even if I've designed everything right on here, there are chances that the chips you buy and use, until you've used them a few times and figured out if they work, might not even work, basically. So I'm fairly confident this is going to work, though. But it is a completely new design, so I've not done any of the parts of this circuit before the way I've designed it. So we shall see. So the first step is going to be to turn on the bench, and we want this set to 2.6 volts. What's this for? This is for a GBA, so for a Game Boy Advanced, and we're about to test if this works basically before we plug it into my personal console. So it's a AA rechargeable clean juice. So we sell, obviously, loads of people sell these now, LiPo, custom LiPos with a USB on. So you install them in the console, plug in the USB, and then you get effectively USB power. I'm updating that now to use AA rechargeables, so people aren't stuck with these custom AA batteries, and then shipping these costs a lot as well. You'll be able to now buy these boards loose like this for as low as £10. So it'll be the cheapest rechargeable circuit you can buy for Game Boy. And you can buy your own AA batteries, or we can also sell them because we're having them made for us with our own little wrap on them. But before we do that, I've got to make sure it works. So this is going to be 2.6 volt. Right, so we know we have 2.6 volts out. Let's now connect up, ground to ground. Output to output, here we go. Let's hope this is good. Okay, good so far. Absolutely no power draw, which is what we want. Otherwise, this won't work sitting at idle. Something for the Sega Game Gear. We may have. It's maybe something you've been waiting for. We'll get to that after the GBA. So the first thing we need to check is, where's my multimeter probes? That we're getting the 2.6 volts on the battery springs. I can't remember where they are. So we tested 1, that'd be nothing. Tested 2. These not quite gripping on right. 2.6, that's ground. So the first issue is, do we not have ground there? Let me try that. Yeah, I don't think we've got a good connection somewhere, even on just the ground part. Let's go to continuity. Disconnect power a minute. So I think that's ground. That's ground. That's a bit of a bad connection. I think I haven't stripped that wiring off. Let's try that again. So now 2.6 volts on there. We should get 2.6 volts on here. There we go. So that's the input voltage. So the obvious test first. Now, fingers crossed. Oh, there you go. Nothing. So, doesn't work yet. Hopefully it's something simple. So we have nothing coming out, and that should be on. So we'll go over to this side, and I will need... I don't know whether this will make any difference, but let's just plug that in. Yeah, it detects there's no battery, so it thinks there's no input voltage at the minute. So let me just pull up the schematics of it. And we can try another one while we wait, because that just might be poorly soldered with them being hand soldered. Let's try the flexible one first. That's the same as the other one now. Let's see if we get any different result on this. There we go, a bit clearer. So there's that. Oops, stabbed a hole through this one. So we're getting something, but not the correct amount there. And it's collapsing under load, so something's not right on there. So it's unlikely going to be just the assembly. Let's see if I can spot an issue on the actual design. Right, so the first thing we should have is we have the battery connection. Yeah, that goes to the copper pole, that goes to there. Have I literally not connected? Oh yeah, that just goes to the battery, the output comes over to here. So that means the battery should go in to the top of that cap. So ground there. Then ground on there. They would work on any 2AA battery circuit, yes. It's just the physical fitment. So I'll probably be making them to fit on other circuits, basically. Right, so the first thing I need to see is, do we get the voltage coming out there? So I don't know if I can get that so you can see while I'm doing this. There's the voltage there, and I'm just going to track now. It should go to the top of this cap. Yes, it does. So we've got power going into the regulator. So that's a good sign in one way. That means pin 4. We should have it going to the bottom of oh, it's upside down. There we go. Should be going to the bottom of this one. Yep, so we still got that as well. So that's good up to that point. SNES, we do a clean RGB that gives you the best output if you've got like an RGB receiver, or you can get like an OSSC to get HDMI out of it as well. But if you go to retro6.co.uk and then send in services and SNES, you've got the options there. Right, so we're getting power into the boost circuit. We've got the inductor, we've got 2 resistors, and simply an output voltage. So there's not much to this. The output voltage should be wherever this one goes to. So the bottom pin. So it should go to there. Oh, good news then. We have voltage. So it's working because there's the 3.3. So why aren't we getting it on the output? Is it a simple mistake somewhere? There's literally nothing left in the circuit that takes us up to the top here. Oh, and now it's working. So it does look like it's working. It's maybe just these enamel wires, because that's literally working. So there's the 3.3. And now if I lower it to, I can't remember what I set this to, but I worked out what the rechargeable AA's low voltage point is. Let me read the notes. And then we can check if this does go into low battery mode. So when 2 batteries are below 2.25, so this should drop. We want this to drop to a lower voltage when I set the input to, say, 2.2. Nearly set it to 22 then. There we go. And that's now dropped to 2.6 volts. So that's now saying it's low voltage. So this is fully working. I know the charge circuit already works because I've already designed the first version that charged the batteries. So I know it recharges the batteries. But I'll still test that anyway. I'll still retest it before it goes into production. But that pretty much means we should be safe to plug this in. But then why did the other one not work? Did we just have bad soldering or bad connection? Is probably all that happened. So it's probably just these grippers making poor contact. Let's try that again. So that's the battery inputs, and then we've still got to test the regulator under load because it might show up fine, and then as soon as you put load on, it collapses. So we're not out of the woods yet. It still might be a problem for us, but hopefully it won't be. Right then, 2.2 on that. And now let me check if we get the voltage. So bear in mind, this is the one a minute ago that didn't show any voltage, and we've changed nothing. We just reconnected it. So I've got a feeling Yeah, 2.2 and this had nothing. You see, this still has nothing. So this one doesn't work. That's weird. Yeah. Let's flip it over. Let's do the same probing on here then to see why. So we have the input voltage going down here, which we do. The input down to there. Was it down to there? Can't remember. It was on one of these. Yeah, that one. So it's going to there. It's going to there, and the output should be here. Yeah. So this one has actually got to be bad soldering. So just bear in mind these are made at the minute. The prototypes are made by hand. So I'm just going to, in fact, if we look at it on the lens, we'll probably see why. So the issue on this one is going to be this chip here. So let's see if we can spot the problem. So it's just got pins either side. And I don't know whether we'll see on this. Yeah, so see those pins aren't very well soldered in there. They look okay, but yeah, so those ones look all right. I think it's more this side that doesn't look good. So if you see, you can just about see, but see that pin there, that third pin, that doesn't look connected to me. So I'll reflow that quickly, see if we can get this working. I could always just use another board, but I might as well try and fix the one we've got. So for this, I'm going to do it under the scope, just because I want to see it and make sure it's right. I'll probably lift this off and then resolder the pads as well. Yeah, the retro scaler's good. I like the retro scalers. I didn't bother resoldering the pads. It's pulled into position. So for now, I'll just reflow them. And let's see if that now works. So we have ground on this one, which to be honest needs a bit of solder because that doesn't hold well. And then we've got the 2.2 volts in. Now that is pulling power that we don't want to. That's a problem. So I think this is now working in one way, but I need to check that on the other. We have an idle current that we don't want sitting there pulling some power. It might be because it's warm. I don't think so though. And now if we go to looking over, ground, got the 2.2 here. Yeah, so I think this one's probably faulty somewhere else. Let's just grab another one then. We know the 0.1 works, this thinner one. So we know the design's working because this one works. So let's just grab another one of the 0.2s. We're testing prototypes at the minute. So this is a new prototype for the GBA console. So it's an AA rechargeable battery mod, basically. These are just the prototypes that we're trying to get working, but one of them works, the other one doesn't. So we're just going through and testing them, but obviously these are hand assembled samples from the factory, so sometimes you deal with basically poor soldering, which is what it looks like there. The one that's not working is that's just got poor soldering basically. So I'm just gonna use another one. and hope this one works. That on there. That's on. Let's see if we get the 2.2. And we get 2.6. That's working. So this one's a fully working board. So you'll see ground, battery input we've got set to the low 2.2 to trigger the low mode. So the output will be 2.6, which it is. And we up this to 3 volts. Was it 3 volts? No, 2.6. Which is fully charged AAs. And now the output will be 3.3. So this is a fully working board. And now we just got to test it under load. So let's just put a cross on him so we don't get mixed up. Move him out the way, and let's go for the install. So we'll remove these pads off. And these won't be, probably shouldn't be on the final one. This is laser cut, so these little laser burns because it's a small flexible board. But we'll tell the factory to try and not end up with these tiny laser burns for visuals. Now let's put this down, so I'm about to put the console down. And this is where the install should be nice and easy. So that one's the 0.1. Right, so to install this, we basically place it upright like this, install the batteries, so you can install this one first, install the other one this way, and this now folds over, and you can pre-fold these down like so, and now all you've got to do is line them up with the holes in the battery there and push down. And I've done this where this does, what it did for me at least, slide down nice and easy. So that one's a bit firmer. So maybe we lift that one up, place it on, and place down. And I think it's just trying to figure out the best way of installing these, because when I've done this the first time, it went in fine. These seem a little bit tight now. But I did this before where you just basically hover over and these push down nicely. Seem to be more flexible now. So that one's gone in. This one, there we go, it's just about going in. I think it's going to need reinforcing, so we probably need to strengthen these parts here with something or somehow, because that's quite tight to install and it shouldn't be that tight. So I'll figure out the best way of installing these. I mean, I can push with tweezers like that, but it's not something you ideally want to have to do, is kind of push to install. But for now, I'll just do that to get it in. You can't place it under the batteries because you need the USB port to come out. So like this, when that goes in, you need the USB port to be at the top. So that's all installed and fitted. Let's just see. There we go, working, but I didn't actually test while it was in. The reason I have these test pads on is while it's in like this and you're wondering if it's working, you can basically get your multimeter and you can test if you've got a good connection. So we can test both batteries as well as the final output stage. Yeah, we want to work on a good way of installing them. That's just going to be a challenge of trying a few ways and finding the best way that works so people can repeat and install it nice and easy. So if you go on the ground pad here and then go on the first pad over here, you can see you can measure the first battery cell at 1.28, then the second battery cell at 2.6, so you know they're in series and working. Then you can measure the output voltage to the Game Boy, and when we turn on, let's see if we're still getting that 3.3, and we are. So even under full load with clean light, clean screen, max brightness, LEDs on, volume up max, this seems to be working. So let's turn the volume down a little bit, and we're going to obviously have to play some Pokemon Emerald. So I'm going to turn them. We know it's now working under load, so I'm just going to turn these LEDs down a bit so they're not as glary. And let's turn them off, and then let's just put the back cover on so it's like it is. At least that's super easy. That clicks in perfect, no struggles whatsoever, and looks dead clean. So I'm happy with that. And now you'll see as well, I've angled the overhead light so I can place things flat on the bench and not get the glare. So let's just play a little bit of Pokemon and make sure this is stable and works. And then on here, I think we've got a red LED when it goes low as well. So I'll leave this in mind. This is my personal Game Boy, and I'll literally play this tonight until it's done. Yeah, you can play while it's charging. We'll test that as well. And I'll show you I already tested the charge circuit to the last version. That worked fine. So let's just get a USB plug. And I used to have the ones that told you the current. Let me see if I've still got one. I should have. So whether this will work, and then you can see. Oh, that's fully zoomed out. So sometimes these pass-through things don't work right, but if it does on this, you'll see. So now you see the charge light there. You can see it's charging the batteries by 0.5 amp. Let's turn that down. So now you can see the batteries are charging, and we're still playing. No noise at all on the audio, which is what you want. So charging works great. This little LED at the bottom, you can see in there, the red LED is charging and goes off when it's charged. So we'll unplug that. We know that's working. But yeah, it's all looking good. And then I'm going to do exactly this kind of setup for all of the other ones. So I can now rapidly move this design over to GBC, GBO, GBP. I'll do one for and get AAAs made. Game Gear is going to be AAAs. And bear in mind, like I said, this is production ready, £10 if you buy 30 of them, £13 if you buy one. So this is now the cheapest USB rechargeable kit for GBA, and it's going to be the cheapest for every console. So this is becoming the new standard, and we're getting rid of these custom lipos. So this one now is gone. We've got like 4 left, so these are gone. This will take a few more weeks to get into production and on the shelves, so you won't be able to buy this one again from us. We're replacing this now with this, and look how much cleaner that is. So advancements in how I've made it, how I've designed it, used a lot less components, made it cheaper because I'm making more of them. So just progression in the design phase, basically. So now we can start offering these to customers cheaper, and you get a lovely clean finish on the back. No issues installing the covers, which was another complaint. Yeah, I might want to patent it actually, because that will stop AliExpress being able to do it. But I think we are. Correct me if I'm wrong, but I don't think there's a single GBA, because I can patent it specifically to GBA. I don't think there's a single GBA AA rechargeable design. And there might not even be any for retro consoles that drop in, and if so, I'll patent the whole lot. And then at least we can protect against clones. I'm not so much for that. I hate the legal side. I've dealt with it plenty before. I don't really want to bother with the legal. Plus, they're going to struggle to compete with our pricing, even if they clone it, because we're now making thousands at a time of all products. We don't make 500 anymore. We're doing mass of every product to keep the price down. And then obviously this is the clean screen for those that don't know. So we can turn the brightness down a bit. you can turn the color mode to normal. Well, this is the clean screen mode, so see how accurate the colors are now. And this is what everybody else's screen looks like. So that's clean screen mode that fixes the greens. That's the standard black and white and DMG style. So I'm going to put it back into classic mode. Pixel grid, you can turn off completely. So it depends, I guess, where the camera's focusing, whether you're going to see the pixel grid. You probably won't. Let me just try and keep it going. So you can see the pixel grid on this awesome camera. That's full pixel grid. That's horizontal. That's vertical. And that's off. So you can literally play it. Zoom out a little bit. You can play it whether you want just completely non-pixel, the vertical, horizontal, or pixel grid. I personally play it with a pixel grid like this because that looks just like, that is the closest thing that looks just like an original GBA. So that's how I played. If you're in the EU, Silent Modding and Retro Reese will stock this and you don't have to pay taxes. I'll basically show them this and say that it's going to come out in a few weeks, and they'll usually order it pretty much straight away. So you'll have it in them stores fairly quick. Yeah, that's a good point actually as well. You can now also just carry spare AAs. So say you're on a long flight with no charger. Whereas this, you're kind of screwed when it runs out, it runs out. With these AAs, you can swap them. We just need to try and make that inserting somehow a better experience, or just practice how we're going to install it into the back. It's just something we've got to figure out. It's something we can do. That's a minor thing, but the product itself is functional and working, so I'm happy for that. The sites are, let me chuck it in here. You've got silentmodding.com and you've got retroreese.com, I believe. It might be .de. Let me just double check the Retro Reese one. Retroreese.de is the other one. So you have, where's it gone? Apparently now it's blocked my it's blocked TikTok for posting links to sites to buy things. So I think the TikTok has disappeared. So that's that one working. What I'll probably do now then is, because apparently I can't post links in my own video, we'll probably end this stream and re-jump on if it's disappeared, because it looks like it has. Basically, it's kind of dropped. Yeah, so that's basically something apparently TikTok's warning me about, that I can't link. That's bizarre. Can't link things to sales, even though loads of people do. This is a AA rechargeable clean juice for the GBA, so you can use now rechargeable AAs and our little clean juice AA that just inserts in between the batteries, and it lets you now play a Game Boy and use rechargeable AAs instead of a custom LiPo like this, basically. But yeah, seems to be all working. I'm going to play this now, obviously tonight, to drain this fully, check the low battery indicator comes on. When it's fully drained, I'm going to charge it. And then once it's charged, I'm going to measure the battery voltage, leave it for 2 or 3 days to make sure there's no drain. And then if there isn't, this will go into mass production, basically. So this one's going to have been a nice quick stream anyway. That's that one done. I'm going to end the stream and come straight back on, because we've just basically been booted by TikTok for advertising apparently our own websites. So yeah, this one's all working. I'm just going to end the stream and come straight back on, and then we're going to be doing, just so you know what you're coming back on for, we're going to be doing these now. So we have, well, I don't want to open them because we'll start that on the next stream, but you can see we've got the re-PCB, and it's the 1A6. So if this works, this is also going to go into production. So yeah, if you want to join back in a minute, I'm just going to end the stream and start it up again, basically. I don't think I can kind of end just TikTok and restart it. I think I have to end everything, so